Let F1 and F2 be the foci and O be the midpoint of the line segment F1, F2. This is F1, this is F2, that's O. Let O be the origin and the length from O through F2 be the positive x-axis and through F1 be the negative x-axis. So that's F1 and that's F2, correct. Let the length through O perpendicular to the x-axis be the y-axis, so that's your y-axis. Let the coordinate of F1, this coordinate will be minus c by 0 and this would be c comma 0. Let p x comma y be any point on the ellipse such that the sum of the distance from P to the two foci is 2a. That's the definition or the idea behind your ellipse. Say this is point P, x comma y. So this length and this length put together, that is, let me write it in terms of an equation, pf1 plus pf2 is equal to 2a. So that's important for us to keep in mind. Again, as usual, this derivation also starts with the distance formula. Okay, so first we will start off with writing the distance formula. We'll need the space. So distance formula will be x2 minus x1 the whole square plus y2 minus y1 the whole square to the power of half. So that's your distance formula, right? Now let's apply it to each of this. Therefore we have, say, x plus c the whole square. So I'm applying it to pf1 plus y square to the power of half. Then the next term would be x minus c the whole square plus y square to the power of half. This is equal to 2 times of a, right? Now we need to rearrange this. So we have the same expression. Let me copy it off. But I'm putting across this to the right hand side. So this will be negative. Is that correct? Now we'll square both the sides. So next step would be squaring both sides. So we'll end up with this entire thing has a root and a square, so they will get cancelled. And this would be of the form 2a minus x minus c the whole square plus y square to the power of half the whole square again. And let's take up the RHS. So a bit of simplification is required. So we have 4a square, then we have plus x minus c the whole square plus y square, right? This is of the form a minus b the whole square minus 2 into a into b. So basically this is 4a into x minus c the whole square plus y square, the root of this. So that is your RHS. So your LHS will continue to be x plus c the whole square plus y square. Okay, again I'm just rearranging things, nothing else. So we have y square, that is common. We can cancel that. Now a bit of rearranging and expanding all of that is what we are looking at. So again we have 4a square over here and x minus c the whole square, I'm expanding it, minus 2xc. Then we still have your minus 4a times of x minus c the whole square plus y square to the power of half. And this is equal to, on the RHS we have x square plus c square plus 2xc. Again we have few things that we can cancel. X square, c square, c square. Right? A bit of rearranging, we have 4a square over here minus 2xc, I will transpose it. So we have 4a square minus 4a x minus c the whole square plus y square to the power of half, and that is equal to 4xc. Right? And we can see that all the terms have 4 common. So we'll divide with 4. So the same expression without 4's. And we have xc. Agree? Now, again we need to somehow simplify this and all of that. So how will we go about doing this? Again, rearranging. So we'll need to rearrange. So that we have this. By the way, there is a root. We can't miss that. Because of that only we need to solve so much. And this is equal to, I can just write it as 0.5. That's easier notation. Right? And then here we have xc minus a square. And this is minus, by the way. And now when we expand it, when we square it. So squaring both the sides again. So we end up with this being a square, and this square and square root gets cancelled over here, and we have xc minus a square the whole square. And now again we'll expand it, a square. So we have x square plus c square minus 2xc plus y square, right? So we are squaring each of the terms. So there are 2 subterms over here. So this entire thing had a 0.5 and square, so that will get cancelled. And I'm expanding x minus c the whole square. Remember, we have 0.5 into 2 over here. Okay. And on the right hand side, we have x square c square plus a to the power of 4 minus 2xc a square. Agree? Again, this entire thing has to do with simplification. So then we will use distributive property. So we have x square a square plus c square a square minus 2xc a square plus y square a square is equal to x square c square plus a to the power of 4 minus 2xc a square. Anything that we can cancel? Yes, we have these 2 expressions that are the same, and right, done. I don't think we can cancel anything else. No. Now, what else can we do? Let's rearrange them. So rearrange them so that we have all the x's at one end. So we have x and x over there. So x square a square minus x square c square along with the y. Then we have y square a square. And all the constants on the right hand side. So we have a to the power of 4 minus c square a square. Agree? Now I'm going to take common. So we have x square common over here. We have a square minus c square. Then we have plus a square y square. And here I have a square common. And so we end up with a square minus c square. Right? But what is a square minus c square? Think about it. It's not that hard. Yes. Substituting b square, which is equal to a square minus c square. That's the relationship between a, b, c, is it not? And so basically this is b square, this is b square, and this will turn out to be b square plus a square y square. We're almost done. It's equal to a square b square, and at last we are going to divide this entire expression with a square b square, and we have the following result: x square by a square plus y square by b square is equal to 1. The idea of the derivation is not hard, but yes, the solution is lengthy.